All right, so when we're looking at these first few problems, all we're doing is determining whether the function represents growth or decay. So in order to figure out growth or decay, growth, b is greater than 1. Decay, b has to be what? In between 0 and 1. Okay? So 0 is going to be less 1.
What if it's like a negative?
Doesn't work. All right, then it's neither. Okay, so in this case, 3 is greater than 1. So this is a growth function. Over here, it's in between 0 and 1. So it's a decay function. All right. Numbers 3 to 5. Write the exponential function in logarithmic form. Remember, the exponent is always the answer of the logarithm, right? So we'd have log base of some number, we'll say x, equals the exponent, right? So here the base is 2, so log base 2 of 128 equals 7, right? It's always equal to the exponent.
Yes, sir.
Yeah. And number 4, we'll have log base 5 of 625 equals 4.
How many questions are going to be
This, however many are in here. 25.
Go.
And it's multiple choice. Log base 4 of 65 equals x. Alright? Number 6. Are we going number 3 to 5? Easy, right? Just converting. Number 6, we're converting the other way.
Wait, so 5 equals x?
Number 6. So the base is 9. We know it's always equal to the exponent. So squared equals 81. Now remember, here the base is 10. So 10 to the x equals 4. And here we have what? 4 to the 20 equals x. All right? Quite simple there. Now we have to evaluate these. So we have to remember here, if I was to write log base b of x equals a, it doesn't matter what we say here. This is the same as saying what? B to the power of a equals x. So for number 3, for number 9, what we're really asking ourselves is 3 to what power equals 27? Well, 3 to the 3rd is 27. Here we're saying 8 to what power equals 8? 8 to the power of 1.
Oh.
11, we're saying what? 9 to what power equals 1? Well, anything to the power of 0 is equal to 1 except for 0.
So, sir, you know how to try.
Number 12, here we're saying 7 to the power of
4.
What equals 7 to the 4th, right? This is kind of redundant, right? So the answer is just what? 4. All right. 13, we have 6 to the power of what equals 1/6. So whenever it's a fraction, just look at the denominator. So 6 to what power is 6? 6 to the power of 1. To make this a fraction, it has to be negative. So this is just negative 1.
Okay, but how though? That.
Number 14. So this exponent we could bring to the front and say 2 log 10,000. Don't forget the base here is 10. So 10 to what power equals 10,000? 10 to the power of what? 4. So this is 4. And 2 times 4 equals 8. So the whole thing is equal 8. So I count the zeros. 1, 2, 3, 4. So it's to the power of 4. Right? Down here, so bring the 4 to the front.
And you said if you count the zero, go.
Yeah.
Oh, that's lit.
So we know this is equal to what? 3 to what power is 27? 3 to the third. 4 times 3 is 12. So this is just equal to 12. In 16, so we have 54 raised to the power of log base 54. So since this base of that exponent is the same as the base of the log, it cancels, and we just get 200.
Always.
Always. Now a very similar thing happens in 17. But we want the e, so remember that natural log has a base of e. Just like these had the same base, right? So what we want is this 3 to come up here first. So we have e to the power of natural log x to the third. All right? So now e and natural log will cancel since that's the same base. And we're just left with x to the third. So we have to simplify these. Okay, simplify. So addition means what? All right, so we're going to have log base 5 of 1 times 25, which is 25. Well, 5 to what power is 25?
2.
Oh, my
2.
God, 2. Oh,
So we get
wow.
2 as an answer.
I'm looking for this. All right, you fan.
All right, in number 19, we're multiplying again. So log base 4 is 16 times 64 is 1,024.
Okay, that's gonna take me a minute on the test.
How small?
Small enough. So 4 to what power is 1024?
5.
5.
How'd you do that so quick, Steven?
Let's see. I can't.
You're wasting me.
Well, you know that 4 to the third, you have to know that, is 64.
And times that by 4.
Times that by 4 is going to give us a 6, a 1, 24, 25. And then let's go 4 again. Right? So that gives me 24. That's 20 plus that is 22. 8, 9, 10. And there's a number. So 3, 4, 5. So to the power of 5.
Or you just can count that 6. You get 16, you cut 2 powers.
Absolutely. Right? 4 is what? So 16 is 4 squared. 64 is 4 to the third. 2 and 3 is 5.
That always applies?
Yes.
All right, I'm doing that.
If it works. Sometimes it may not work. If it doesn't go in perfect, then it's not going to work.
What the heck?
Number 20.
A flight is going to camera.
Yeah. There it is.
Oh, I'm dead.
I want to be star.
Oh my God.
20. So we have log.
It wanted to be in the video so bad.
4 times 25 is 100.
Oh, 2.
So 10 to the power of what is 100? 10 to the power of 2.
Homeboy.
21. We're subtracting now, so we have to divide. Log base 2 of 24 divided by 3. Log base 2 of 8. 2 to what power gives me 8? 3.
I wouldn't say forward. Can't mess up like that on test.
Subtraction means division. Natural log of x divided by 4. Nothing else we can do there. 23. Divide. Log base 6 of 72 over 2. Well, that gives me log base 6 of 36, which is 6 to what power is 36?
2.
2.
How about if the number is not divisible?
Like, if that was 40,
If it was like 72 over 3.
then you just leave it. But that's divisible.
No decimals.
Well, 72 divided by 3 works. How about like 72 divided by 7? That won't work. Just leave it. Yeah. Yeah, don't get a decimal. You can't. You look at it. 24. So change to base 10. This is very easy. So we're just going to have log, right? Because the base is 10. Now remember this. I like doing it this way. The base here is 4, right? So remember base bottom. So this goes here on the bottom.
He said